Alright, Mr. Gatekeeper here. Boy, do I have a very neat amplifier here. You don't see a lot of these floating around, but before I get started, I need to document that this was bent pretty bad on its way here from Florida, and I'm going to do my best at bending all of this back. I just wanted to document it. It's bent the front right there along with that part of the fin. I mean, this had to be thrown down or something thrown on top of it pretty bad. It didn't have a whole lot of big bubble wrap, but still it was packed pretty good, especially not this to happen. Now this side is fine, as you can see. That's what it looks like. It was mostly done on the this side down here. This is bent back. Let's see, that fin looks fine right here, just the back. I should be able to get that bent back fine. And the top, this mount has been pushed down and bent down, if you can see, which I don't know how much of this was done already, but from what I understand, it was in perfect condition. So this is just bent down and pushed down, which like I say, I'm gonna do my best to get this all bent back. This is just the main thing I'm worried about, but I will do my best. And the back right here, it appears that this has been just pushed in, bent in, you see? God dang it, I hate to see this. I mean, I hate to see this with a freaking passion, because this amp is hard to come by. Very hard to come by. And here's what makes it even more worse. The fella dropped by. He dropped by on the way, I think, vacation, I believe, or to see some family. And we got to talking and forgot to even take this out of his car to leave it here. So he had to ship it. We got to talking. He dropped off another amplifier and some other stuff, and just got to talking, and we both, I forgot to remind him and he forgot to unload it, so he had to package it, and that sucks. The plug is still fine, it seems. I mean, you know, there's really no need for these plugs like this. They just wanted to give you some quick disconnects, but the problem is you got a big square hole here. I mean, yeah, you could put something in there to wall it off and drill a hole, put some big, I don't know. I'm gonna have to probably call and talk to you before I really get into this big, because looks like they've probably, so this is a plug that you would use for like a remote, but I mean, it is heavy duty. Had to take this off, this screw out to get in here and try to put some bigger wires in there or something. But things being square, like if we took this out, you'd have a square there. So the only way to is to put a piece of aluminum, stock aluminum or something, to cover it up, and then drill a hole through the aluminum to get, you know, some bigger wire out of it. But dude, I hate this with a passion. This is a cool amp. It's a blast from the past. It's in beautiful condition. You know, not otherwise the bends and everything. But I just want to document that before I got into it. This is why I take absolute, and I mean absolute, pride in shipping. And anybody that's ever received something from me in the mail knows this. I go to the extra mile, and it's expensive to go to the extra mile. Not everybody has, you know, $40, $50, $60, $100 worth of just big fat bubble shipping materials. Mine's going blank. Bubble wrap, goodness. That bubble wrap is expensive. I just recently went up on it. So I'm constantly having to spend money. I need to go ahead and just buy me a big, huge 100-foot roll or something, 500-foot roll. But not everybody has that type of stuff on hand, so you can kind of only use what you can use. And if you go to Walmart, they've got some big bubble wrap up there, but it's still not as good quality as what you can get from UPS. That's where I get my bubble wrap, UPS, but I don't ship through UPS unless somebody just asks me to. And but this right here is a prime example of why I have to go to the extra mile and package a amplifier to the point to where I can take my fingers and push on it hard and not feel the amp at all, even especially on the corners. That's what you really want to do. Take your thumb and push hard. If you feel the corner at all, it's not wrapped good enough. I learned that with the very first big amp I ever shipped. That's when I learned that. But like I said, even though you still had bubble wrap in here with this, and with the amount of bubble wrap you used, it still shouldn't have turned out like this. You just got unlucky. That's all there is to it. But I'm gonna do my best to get all this stuff bent out, man, and I'll be back and I'll show you what I was able to do. Now, before I did anything else, I just wanted to document, let you see what happened. See, it's pushed it all the way down. I think you're going to need to do a claim with the post office, regardless. I know if you didn't put any insurance on it, all you're going to be able to get is $50. But this is worth doing a claim, an insurance claim. This is pitiful. This is pitiful. I haven't had a box get here this bent up in a while. Every once in a while, you know, somebody will send one that, like I just had a guy that sent one, but he did not wrap it up at all. He literally got the amp. It was a Texas Star 500. He put it in the priority box. It looks like he put like a rag, 2 or 3 rags in there, and that was it. 2 or 3 rags, and the front of the Texas Star front faceplate bent completely in, but the frame was bent in too. But I could just push the frame back, and I had to give him a new front. But that was it. But this right here is rough. This was hit from multiple angles. And this is such a neat amp. I mean, this right here is like the top of the line 5-pill from back in the days, 30-40 years ago. Rocking with the 421s, you know. He wants me to get in here and mic in all these tremors, and then get some metals put on the output, do a power wire upgrade big time. You've got the wire coming in like this from the fuse panel and coming up to this switch right here, which is the power switch. What they should have done is took this wire right here and brought it over to this other transformer right here, and just run a small wire up to the power switch. But that's not what they did. They've pretty much brought this 10 gauge wire from here over to this one, and got it tied into this over here. So I mean, it definitely could use some work, no doubt about it. We've got 3 relays here too. I'm gonna have to get in here. I have not had this particular amp, I don't believe, sitting on the bench ever. So it's going to be cool to get in here. I may even draw a few schematics too, just for documentation's sake. Looks like they got a bias circuit implemented right here, possibly, or is this Class C? Never mind, I think it's just Class C. I think this is for the meter. And take a look at this high-low medium switch. excuse me, high, medium, low switch. Somebody has put a very tiny 1/4 of a watt resistor in here. I don't know who done that, but that definitely looks like maybe the resistor that was right here got burnt or got real brown or something, and they replaced it with maybe the same resistor, but definitely not enough wattage. Shoot, man, I'm gonna holler at you. I don't know if you want to keep it high, low, medium like this. It may be better just to put a dang variable on it, man, so you can have a variable of where you want to be. But that's all up to you, bud. All up to you. I'm gonna let you watch this video, just this portion first before I get started, so you can let me know exactly everything. Well, I hadn't read your letter yet. I need to read your letter, but oh yeah. Yeah, I think I'm gonna draw me a little schematic. This is pretty much the same outline that I built a 1x4 with 421s for a good buddy of mine, Mr. Shockwave, and it turned out great. He's still using it today. This is the first 5-pill with 421s I've seen since then. 421s are great resistors. You could build this box today in this day of time and call it a Golden Eagle 1000 if you're talking about peak watts. But alright, man, I'm still gonna do my best. Even though I get this stuff being out, it's probably not gonna look perfect. Might have some wrinkles in it or whatever. Man, they really, dang it. I'm gonna do my best, bud. Set a meter right here. Yeah, about does make me want to cry, because you don't see a lot of these around. It's like seeing a dang Ferrari that got shipped somewhere and you get it and the front end's banked up and stuff. See, it ain't, yeah. But this ain't total, just the cosmetic needs a little TLC. Alright, I'll be back, man. Get this get the exterior. I'm gonna attack the exterior first, try to get this stuff bent out. Look at this. That ain't good. Huh. Was that ever even yeah, I see where it was glued. Yeah, I see where it was glued now. I wonder if this was added in later. So that's what I'm gonna get in here and concentrate on it. Concentrate and just kind of soak it in. Maybe draw a couple diagrams. See exactly what's going on with this really cool old school amplifier here. Wonder how much these cost back in the days. If you have any idea how much these cost back in the days, drop it in the comments below. I'm curious. Alright, I'll be back. Alrighty, I'm back. And let me turn this power supply off just so I can show you. I got the box bent back pretty decent. I figured out what it is, man. This the aluminum on the front and back is pretty thin, so it's not that hard to bend. And I've got it bent back pretty good. Pretty good. I took about 30-45 minutes and worked with it. And did the best I could. I ran out of space. But anyway, after talking to you, I'm going to be doing a good bit of work to this box. So I kind of want to show it right now the way it is. And also, I remember I said Class C earlier. I got to looking a little bit more. And I have no way of knowing if this was added later or if this is how the box came. I want to give a wild guess that it may have been done later. This right here is a bias relay, okay? And this is there is absolutely no way easier to do a bias voltage than the way this is done, and I am not favorable of this manner. Basically, they got 200 ohm resistors put together to create a 50 ohm resistor, okay? The voltage goes through the 50 ohm resistor and then goes through the choke in the base. I don't really like that much, and I talked to you about it on the phone, but here's the thing about it. It's not working right now. The relay is keying, okay? It's actually keying. It's actuating, but there's no voltage going here, and I checked on here to see if there's even voltage going to the pin that these wires are soldered on, and there isn't. So it's one or two things. Either the mechanism in here is bad on this side of the relay, or they're not touching well enough. There's voltage going to this pin over here, but not to this pin. What I'm gonna go, and also another thing, the driver section is not even biased. It don't even have any bias going to the driver section. What we're gonna do is go ahead and just take this out and just make it Class C. I know the majority of these amps like this, but back then were Class C anyway. And because I talked to you about that on the phone and everything. And I'm gonna change the whole power distribution system, the way all that's done. This box was built back when there was positive grounded vehicles, and so I'm gonna go ahead and allow the box to use this heat sink and the frame as a ground plane. It's gonna make things a lot better. It's gonna have a better ground plane, especially for amps like this that are etched like this, where you don't have as much of a ground plane on the board. And we'll get all these trimmers out. And just to document, you were right. Another thing we're going to do is we're going to take this out right here. I know you said you didn't like this, and we're just going to throw a variable on there for you. And you were right, man, about this thing only doing pretty much about 300 watts right now. That's all the way up. PEP 500 watt slug. We are looking at the middle scale. Oh, right there at 300 watts. So that's the baseline before I do anything to it, 300 watts. And we got the meter right here. Oh, that's just going all the way. I don't know what exactly I'm going to do about that. We'll check it and see. I'll maybe figure out something. But this meter right here is actually just hooked up to the input right here. So it's just reading what you're putting into the amplifier. So I don't know how that's going to work. Once I put the variable in there, I'll have to see. Might have to make some adjustment to it. I don't know. We'll figure it out, man. So I'll be back. Alrighty, I've got a good bit done. This is day 2. As you can take a look here at all the parts I've took out of here. So I got a good bit done. Got a couple more things I'm going to do. These right here, just up for now while I was getting the box tuned up. I'm going to replace them with some more heavier duty caps. But I got the variable installed. Here's the new hot bus, just to make sure this thing is going to get the absolute maximum current possible. Instead of just coming off the hot part of this switch with one wire to the hot bus, I'll come down with 3 individual 10 gauge Teflon wires. And as you can see, the camera's lagging up. I don't know if it's lagging up while I'm recording. Hopefully not. As you can see, I actually did this because it was going to be a little easier for me, because if you can kind of look down here, there's really nowhere where you can just come down with a positive wire. Now put it in the refrigerator for me. Appreciate it. So anyway, there's really nowhere you can come down with a positive with a power wire right there. So I was thinking about the best way to get the power distributed to both of these transformers without even going on the back and having to come over the main splitter right here, is just to do it like this right here and feed each individual collector, because there was a perfect amount of space right here on the collector pad right here for each power wire. And now you have more than 6 to 8 times more inductance now on these power wires. This is going to reject a massive amount better of the ripple on your hot wire to make sure there is minimum RF on the DC wire going back into your vehicle. Okay, these beads right here are so high in permeability. 1 wrap equals 3 nanohenries. Not one wrap, one going through, which is considered a wrap, just going through the bead. So this is putting a massive amount of inductance on the power wires. So that's going to be minimum ripple going back on your DC line. I went ahead and dropped 120 picofarad caps from collector to ground, which was not on here originally. This is going to help a little bit for stability on the output tune of the circuit. Went ahead and mic'd in the trimmers for the input right here. Mic the trimmer for in between right here, which is what this capacitor is right here. Mic these in on the output of the driver circuit. The way this input is done, you do not need a input tuning cap. There wasn't one anyway, but I went ahead and added one just in case I could get the input tuned down just a tad bit, but it didn't do nothing but hurt it. And here's your Class C chokes now. Just putting it right there about 12 microhenries or so on your Class C, on your chokes there to ground. And here's your choke now that's powering the driver circuit. The way they did have it powered was coming off the front switch over here. Actually, they went off the front switch and went directly to here. That's the way they did have it powered. So now this thin wire right here is just controlling your LEDs, the lamp over here, and your relay. And that's the way, really, if you ask me, it really should be done. So this thing has 2 16-gauge wires going to the output of the driver circuit, which is definitely overkill, no doubt about it. And as you can see on the output here, I've got your tuned output tuning cap right here. Okay, when I took the trimmer off, which is one of these trimmers, look at how much trimmers was in this box. I would probably have to say this is the amplifier that beats all other amps I've had on the bench with the amount of trimmers in the box. Now, the only trimmer in this amplifier that I did not agree with was the trimmer on the output, and I'm going to tell you why. These trimmers are only 350 volt trimmers. Okay? Now you have a 5,000 volt capacitor. This cap right here could handle all the way up to a 6-pill with no problem. And this amplifier is not going to do as much as let me put it this way, this amp's not going to do as much as one if I would have built these on a copper board using these transistors, just because the way the amp's designed. You know, that's why they're calling it a Golden Eagle 500. You know, they're pretty much letting you know that this thing should do 500 watts. So, like I said, I'm still not done. I just wanted to kind of give an update, let you take a look at everything that I have done so far. The only tricky thing that's going to be for me, which I'm going to do my best to pull off, is to get this meter working up here again. And basically the way they had it done before, I've drawn schematics and stuff. Whenever I see an amplifier come through for repair or something and it's got something new on it that I haven't seen, I'll document it with pictures or draw some, you know, pictorial type schematics you know, for possible future reference. And this particular one has this wire right here and was soldered to the shield of the coax. So it's pretty much picking up any type of RF from the center conductor of that shield, and goes through a diode right here, and it's basically working on converting it down to a DC voltage. And then it comes over here, and this is the adjustment for it right here, and then this meter is picking up a DC voltage, and it's just giving you a relative. But this right here is just basically just telling you how much you're putting into the amp. Now if this right here was hooked up on the back like Texas Star does, but see, for example, if you make a Texas Star Class C, you'll notice it'll throw the circuit off and you have to readjust it. I may have to get in here. See, I don't know how important this is to you. I may need to call you back and ask you, but I may, you know, this isn't something I normally put on my amps particularly, so I haven't never designed a circuit to do that. So I may just try to, if I can't get this to work as it is, I may just try to duplicate Texas Star since I'm very familiar with it. But anyway, man, so we've got the setup exactly the way we had it before. Okay, now take a look at what the amplifier is doing now. 500 watt slug still. I think it was doing right at 300 last time. Go 500 watts, my friend. Take a look at the dead key. So it's only dead key in 50 watts, which is a good low dead key. I know you wanted me to basically try to get it to where if you're dead key in 4 watts, that it's dead key in about 100. Okay, and so I'm gonna add a little bit of attenuation. Right now I don't have any attenuation at all other than the variable right here. 500 watts, my friend. And I'm gonna throw it on the big supply too and really give it all the juice it needs when I get done. So I'll key it up one more time, and it is doing right there about 200 bird right now too. So of course the peak's gonna come up, the bird's gonna come up. All right, well, I will be back. Alrighty, I got the new RF meter circuit in, and it works absolutely perfect. Just had to change around a few things. The other meter circuit was basically doing it the opposite way, and so I basically had to switch the leads here, unsolder that one, and ground the other lead. But this is the first time I've ever made an RF meter circuit, and I'm gonna take this variable and take that out and measure it and put a fixed resistor in there. But there she is right there. And since you're doing about 500 watts, I adjusted the meter to swing to the 5. Oh, right there, a little bit over the 5. See? Oh dear. Oh dear. Alrighty, man. I'm just glad I got the meter working. I was worried about that. The old meter circuit is, where's it at? Oh, right here. That's the old meter circuit. And it was basically running off the negative. There's a diode and everything right there, and a capacitor. It was running off the negative. This does have less parts, but it basically, it's the way they had it set up. I would have to leave this coax right here ungrounded to the board, which I don't like. I don't like to do that. I like to ground it at both ends. And you would basically be coupling the RF off the coax. But this right here is basically a Texas Stars circuit, and I just added 2 more parts to it to adjust to more of the Class C model, I guess you can say. Alright, man, I got a couple more things I need to do so we can wrap this thing up. I need to get these right here off. I'm going to do all this, and I'm going to clean the box up real good. I got to get that right there mic'd in. and I've got to do some attenuation so that you can put 4 watts in this thing. Try to get it where it's dead key in about 400 watts. I mean, excuse, about 100 watts with a 4 watt dead key. But I know you said you're going to try to keep it around 2 watts. Alright, I'll be back. I know this has turned out to be a long video. A lot more work than I anticipated doing to this thing, no doubt about it. But she's coming along pretty good. Be back. Alright, brother, I'm all done. I know how special this amp meant to you, man. So I mean, I went inside and out, frontwards and backwards, and really did my thing to this amp for you, bud. Just to give you an overview, this is the majority of the parts that came out of the amp. There are a few items that I used towards other modifications in the amplifier. For example, these stands right here. And the RF sample circuit for the meter. Right there. But this is the majority of the items. Components. 1, 2, 3, 4, 5, 6, 7. I think that tops it of how many tremors has been in one amplifier out of any repairs I've ever done. 7 tremors. Wow. Wow. So yeah, man, I went ahead and added some more electrolytics here for you, just for filtering. Went ahead and added feedback circuits. That's what you see right here, the green resistors. Those are 100 ohm resistors. Went ahead and added feedback circuits on every section. Now what I did here is just to strengthen up the ground, because honestly, if you take a look at the amp, this right here is the weakest. Let me get something to point with here. This right here is the weakest part of the amp right here. See this ground plane that the collector of these 2 transistors are soldered to? Take a look how thin it is right there, right here, and back here. Let's see here, where's it at? Right here. Look at that. See how thin that is? That's what's leading the ground from the main ground plane of the board right here for these 2 transistors on this side of their emitters. So that's why I went ahead and made the decision to see, it's already got one ground right here going to the board. This was the factory ground they already had. Okay, I then took another wire right here and went right here, which grounded the back right here for the SO239s. I also put a wire from the SO239. I want to make sure this thing is grounded the best it possibly could be. So therein I just ran another ground, used some 8-gauge wire straight right here to the middle. Went ahead and took the 330s off that I had put on there for testing and put some metals on there for you, some metal 330s. And I believe I have went through everything else, man, already in the video before. And I believe that's it. Got a little bit of padding on here for you. I went down in the padding. I had a 47 on there. I played around with it a little bit and went down just a little bit. And that'll allow you to dead key a little higher, like we were talking about. Like right now with the 1 watt dead key, you don't have a dead key at all. I know you said you're going to be running about a 2 watt at least. So with a 2 watt dead key, then you'll have a dead key then. And you can adjust it up. I would try to, if all possible, I would try to keep your dead key at around 50 watts with this amplifier, just to be safe. Because, you know, it's just the way the amp's designed. You know, it ain't really that I came in here and redesigned the amplifier. I worked with what was already here and just bricked it, what I like to call bricked it, beefed it up as a brick. You know, the power wires. Look at this. All it had was this wire right here in the beginning that was feeding to this transformer, and then they got a wire on the board that goes over to this transformer. Now you have 4 separate wires, one 16 gauge wire per transistor, and then more inductance to keep the RF off the DC line. Right here is, you know, 10 times overkill, but I just went ahead and did it for the fun of it. And this right here, I don't have the wire because I cut it out of the ferrite bead, because I reused the ferrite bead, but it was some very thin wire, like close to 20 gauge wire that was feeding the driver. So this thing is built like a brick now, man. Now instead of having a 350 volt trimmer for your output tuning capacitor, now you have a, what was that, a 6,000 volt cap? 5,000 volt cap. And these are the old school, new old stock capacitors that can really take a beating. I like to call them power capacitors. You got your variable and all that good stuff. And we got the meter working. I mainly just wanted to show you the outcome of it. And of course, and this thing is pulling some current too. It's already shut my power supply off a few times that I'm running off of, which is this little servo supply. So I'm already pulling a little bit too much as it is. Oh, see, it's already doing 500 plus, which is 200 more than what it was doing before. And I have seen as much as about 250 bird out of it. And like I said, what I was just talking about just then, oh, let me show you the input reflect too while we're at it. Alright, variables all the way up. See? Here's your input reflect. Do-dia. Do-dia. Barely nothing at all. And it did have about a watt, right there, about 1 watt of input reflect before I got started. And just doing some of the modifications that I did, lowered it down. And of course, when I put this 22 ohm resistor, that does soak up a little bit of the input reflect. I think without this on there, it has somewhere around a little bit over 1/4 of a watt, and that soaks up, you know, the majority of that. That's just a reality that you can't really get away from. Attenuation does soak up reflect. Some people actually use that to trick you. They'll add attenuation to hide reflect. And yes, it does help keep reflect from getting back to the transmitter, but it's best to try to get the reflect out of there so you don't have to do something like that. If you can do it, of course. So there you go, man. Kind of like, I like to kind of call it like a time travel modification, you know. Taking the old school and transforming it to a new school. Like I said, I didn't change the circuit. I just bricked it out, beefed it up as much as I possibly knew how to do. And there's a new addition to my book of knowledge. It keeps getting bigger and bigger as time goes on. So if anybody's wanting to know how to make a circuit for a relative output meter, I'll leave the camera right here just for a second so you can take a screenshot and print it out if you want to. It's pretty much a pretty much just took it straight from the Texas Star circuit and just made added this right here just to be safe. Since we're dealing with DC, I know there ain't gonna be no DC really coming back, but just makes me feel better. Put a blocking capacitor. You know, it's really coupling, but it's also a blocking capacitor as well. And then this right here, so you can adjust it. And the reason why this right here is so important, because I don't know the characteristics of this meter. And I could, you know, unsoldered it and did some mathematical equations to figure out exactly what type of meter it is. But so there you go. That's the first time I've ever done. I've always thought about doing one and just never had the chance to. And I mean, it worked like a charm. Like a charm. Oh yeah. Oh yeah. And see, it's going all the way back to 0 because I ain't got no dead key right now. And once you increase your dead key up to 2 watts, and then the dead key is going to come up. And I could do that, but I'd squeeze up under this table. That's why I can't wait to get my my building, and it can't come quick enough, so I can have everything right there in front of me within hand's reach, and just be, you know, organized and just a lot better. And the videos will be a lot better too, because I'll have proper equipment. But you know, all that's got to be bought by me. I ain't got nobody to help me out with that kind of stuff at the moment. Maybe one of these days I'll have a rich investor come across me. All right, 73s, bud. Hope you enjoy. Mr. Gatekeeper, northeast end of Georgia. God bless. I'm gone. Bye-bye. I'm hitting the sack, man. I'm gone.